So in 7.7, we're going to revisit something that up to this point we had been essentially avoiding or dismissing as it was a scenario that was not a part of our real number system. And that is the idea of a square root of a negative value. So again, this does not exist in the real number system. However, we're going to expand beyond the real numbers to create this unit called the imaginary unit to represent this thing that does not exist in the real numbers. So the square root of -1, we are going to represent with this unit, not a variable, but an actual letter that represents this quantity as the letter I. So think of I for imaginary, and so that represents this issue that we have in the real number system. But what that lets us do is it lets us work with quantities that would otherwise not be in our real number system by defining this unit. Because with this square root of -9, I can think of -9 as -1 times 9. And then we can use our property of breaking apart a radical through multiplication like that. That allows us to look at the square root of -1 as an I, and now this is a square root of 9 that we can calculate, which is a 3, and then we just write it in the more traditional form of the coefficient first, so 3i, or 3 times I. But that is a way we can represent this quantity. Now, when you see that I, this makes this what we call an imaginary number. And we'll talk a little bit more about that and how that relates to what we know about the real numbers. But let's get some more practice with just working with this negative under the square root and with this I in general. So again, square root of -36, I could look at, and you don't have to write the step every time, but you could break it apart as the -1 and the 36, which is square root of -1 and square root of 36. So that becomes an I, and that becomes a 6. So you get 6i. Next one, square root of -50. So I'm going to go ahead and stop writing this step and just say that when I see a negative on the inside, I know that turns into an I on the outside, right? That's also important. I is outside of the radical. You simplify square root of -1 into just the letter I. You'll never see I on the inside of the radical here. So I could turn this into I times the square root of 50, and then I need to still simplify this 50. So 50, if I know that breaks apart to 25 and 2, and 25 breaks apart to 5 and 5, we can see that this 25 will lead to a 5 on the outside, right? This is a perfect square. So this 5 was on the outside along with that I, and this 2 is the only thing left on the inside. So this is the common way to write a term that has both a number and an I outside of the radical. Number first, then I, then your radical with whatever was left on the inside. Okay? The next one, don't let this negative sign trick you. Don't think of this as a negative and a negative as a positive. We cannot bring this negative in, but we can take that negative and think of it as that would result as a I on the outside. And in this case, the 7, there's nothing left to reduce there. So you just have negative of I, root 7, as the most you can do there. And then here, with the square root of -6, again, the negative on the inside turns into an I on the outside, and a 6. There's nothing left to do with that. No simplifying, so that would be our final answer there as well. Now, looking at some basic multiplication and division computations here, it's important to understand that when you see this, officially we are not allowed to just multiply the insides, right? If these are both positive quantities, we have a square root value or a radical property that tells us if these indices are the same, we can multiply. But we're not dealing with real numbers here. So the first thing we do is we have to convert that to I root 6 and convert this to I root 8 at least, before we can then say, all right, now let's multiply them. Now, if I multiply these, I've got this I and I on the outside. Well, think of it like it was any other letter. If this was x and x times x is x squared. Let's write I squared here and then come back to that. Now, the square root of 6 and 8 would be multiplied together to give me the square root of 48. Let's go ahead and look at 48. Let's break 48 down to 6 and 8, so 2 and 3, 2 and 4, so 2 and 2. So 48 is 2, 2, 2, 2, and a 3. Okay? So that would mean a 2 can come out and another 2 can come out. So the square root of 48 turns into 4 with a root 3 on the inside. But let's come back to this I squared real quickly, and we'll officially define this on the next page. But this I squared right here, what did I stand for? What does I represent? It's that thing we can't deal with in the real number system. I is the square root of -1. But if that's the case, then this represents the square root of -1 squared. And what we've learned about squaring a square root is it gets you what's inside. So when you have I squared, your result actually is now back to something that does not involve I. When you square I, you get the number -1. So technically there's a -1 there, but that's just 4 times -1. That's just -4 root 3. Our final answer there doesn't involve I at all because of this I squared. So that's something we'll see and actually go into further detail on the next page. But there's just one example of it. Okay, next one here, square root of -6 times 5. So again, I got to deal with this first, turning that into I root 6 times square root of 5. Now I can multiply those square roots and get I times the square root of 30. And that does not simplify any further. 30 does not break down at all. So that would be our final answer there. The next one, square root of -80 over square root of -5. We can definitely do that simplification there and that simplification there, both those negatives turning into i's. Now as a fraction, as one term over one term, we could actually cancel those common factors here. We can cancel those i's completely. Also with the 80, with the root 5 in the denominator, let's rationalize the denominator, right? We do not like square roots in the denominator of our final answers. So let's take both top and bottom times square root of 5. So that's going to turn into square root of 400 over 5. And then let's take that 400 and break it down. 400 breaks down to 20 and 20. So 2 and 10 and 2 and 10 and 2 and 5 and 2 and 5. So it looks like 400 breaks down to 2, 2, 2, 2, 5, 5. So 2, 2, and 5. Looks like everything comes out perfectly. So a 2, and a 5. So 2 times 2 is 4, times 5 is 20. We could have noticed it right there. The square root of 400 is 20. So that turns into a 20 over 5, which reduces nicely down to just a 4. All right, and one more here. We can first start with pulling the I outside the radical. Then we can rationalize the denominator. That'll give me I times the square root of 400. That now is just a 10. And we just saw that the square root of 400 is actually 20. So this is 20i over 10. So reduce that down to a 2i.